All right. Hello, everyone. Welcome back to Comp 2160 Programming Practices. I hope that you are all doing okay today. I'm feeling happy today because it's Thursday. And while I like spending time with all of you, and I'm grateful that we can all be in the same place together, I'm looking forward to not seeing you tomorrow. These 6-week courses are really cool that I get to see you so often, but it's also nice to get a little bit of a break. The other reason why I'm happy today is because I feel like I accomplished something yesterday. I finished this book. This book is called The Three-Body Problem. I bought this book about 6 months ago, and I have a terrible habit of buying books and then just ignoring them for a really long time. And so I started reading this about a week ago, and then I finished it last night. But I've had it for 6 months. Book review time. This is super not at all anything to do with this course, but this was a good book. It was pretty interesting in terms of the concepts that are in it. And I've never really read a book like this before in the sense that it's been translated from another language. I don't really do that very much. And so the writing style in this I found was like quite different from what I'm used to reading with English, like primarily English prose and fiction. But it was cool. It was a good book. There's a lot of really cool ideas in it. There's 2 more books I think that are in the series, so I might take the time to read those as well, but that'll take at least 18 more months for me to finish those books. Today, what I want to do is I want you to be able to continue this, recognize potentially risky programming techniques and how they differ in different high-level programming languages. We're going to continue today with comparing and contrasting C and Java. So at the very beginning of today's lecture, what I want to do is quickly review the 2 lower program that we converted last class. I've taken a bunch of the comments out of the C version of this program just for what I want to put on my screen so we can take a look at it together. We're also going to try to look a little bit more formally through some of the differences between C and Java related to some of the stuff that we've seen before, so things like types and things like control structures. I want to spend some time looking at using arrays in a C program. One of the things that we're going to discover today about C is that a bunch of the stuff that we get in languages like Java and Python that help us with arrays that seem like they are naturally important things to have in a programming language, C does not have. And so we're going to talk about what those things are in terms of what's been removed, but then also how we, writing C code, can do a better job of making sure that we're using these things safely. I also want to spend some time looking at declaring and using user-defined functions in a C program. So one of the things that you're expected to do in the assignment is to take some methods in a Java program and convert those to functions. So I'd like to take a look at how to do that. And the last part of what I want us to be able to do is I want you to be able to explain how C source code is compiled to machine code. Not like this is a compiler's course. We have a 3,000 level compiler's course that I really feel sad is not offered very often or at all anymore. This is more of a, there are phases to the compilation process that our compiler goes through. So we run this Clang program. And when we run Clang, there's actually 4 different steps that are happening. And I want us to be able to look at those 4 different steps. And what I want to be able to do when we're looking at those 4 different steps is take a look at some of the errors that you might see when you are writing C code and try to put those things together so that when you see those errors when you are writing C code, you'll be able to get some idea of how to get out of that situation. All right. So last class, yesterday, we translated a simple program from Java into C. This program read from standard input. Remember, standard input, for the purposes of where we're at right now, is just me being able to type stuff on my keyboard. It printed stuff to standard output. So again, for the purposes of what we're doing right now, standard output is my little terminal window, the screen that I can see output on. It declared some variables, and it had a loop control structure. It had a while loop in it. The goal that we had was to compare the two languages that we were looking at, C and Java, while we were going through the process of translating that program. So here's the program that we translated. We've got two lower on one side in Java, and we've got two lower on the other side in C. The Java program declares kind of a bunch of stuff related to input readers. So we've got that input stream reader. It declares an integer. It declares this buffered reader for standard input. The Java program has this idea of exceptions. It's got that try-catch block. There was no direct translation into C for us to be able to do anything like that. So we didn't include it in our C program. But once we got to this point on line 22 here, this is where we were starting to be able to do a little bit more of a direct translation. So direct translation here from the Java program was that we said letter is equal to getchar. Getchar gets a single character of input. We were referring to the manual pages frequently when we were looking at this Java, the C source code. So how do I use getchar? What does it return? The loop structure is kind of the same here. In Java, it's while letter is greater than 0. We can say the same thing here in our C program, while letter is greater than 0. In this version that I've got right now, I'm using putchar, but what we did last time was we said printf %c and then two lower letter. And this is what is allowing us to print out a character. So either of these are going to do effectively the same thing. These are both going to accomplish the same thing. And then at the end of the loop, we're saying getchar. The last difference that we've got between our C program and our Java program is that our C program has an exit code. It has a return code from main. In Java, we have public static void main string args, and the void is the return type in public static void main string args. Do we have any questions about this? Yeah. Can we set the return type to be void in C? We have to comment out the return statement, I guess, if we're going to have nothing. It's a warning. And Clang is helpfully suggesting here that we return the type to change the return type of main to int. On Unix and Linux, on the command line, when a program runs, it returns an exit code. And this is like kind of the default behavior for all programs that are running on the command line on a Unix or Linux system. Java programs do return an exit code. You don't return the exit code. The JVM is returning the exit code. One thing that you might notice on my shell, so again, my shell that I'm using here is called fish. I can share my dot files if people want to get the same setup that I've got. On my shell, when I get a non-zero exit code, there's this little X that gets printed out here. This is saying that whatever the command that was last run, in this case it's Clang, whatever it returned, non-zero means there was an error of some kind with its processing. So for us to say void here, it's still going to compile the code. Like, we still got a 2 or lower program out of this, even though there was a warning that was emitted. It's still going to do something, and it will still work. But the idea is that we always want to be able to return to the shell, or whatever was calling us, what the exit code was, so how we exited the program. It's a good question. Thank you. Any other questions? We're good? We're good. Okay. I want to take some time now to shout at you a little bit about the differences between C and Java. In a little bit of time, we're going to start doing some coding, and I'd like you to code along with me. Again, the goal with coding along with me is not just getting a program working out at the end, but it's getting a feel for how to type C programs. It is superficially similar to Java in terms of, like, we've got braces all over the place, we use semicolons at the end of the line, but there are certain keys and characters and things that we're going to be doing when we're typing C programs that are just different enough that it's going to be good to get a feel for how to do it. Is that me talking to myself? That's a really weird, that's very weird. Okay, so we're talking a lot about C and Java right now, but I do want to take a step back and think about, like, what comparisons between languages might you want to make if you were going from Java to Python, if you're going from Python to C, if you're going from C to Prolog, different programming languages, what kinds of things are you going to be thinking about when you're comparing those to each other? The first thing that you want to look at when you're thinking about comparing programming languages to each other to help prime yourself to get ready to learn a new programming language. And so the context here in my mind is, I've graduated university, excellent. I'm feeling good, I've finished my degree, I have a job offer, so I'm feeling even better, but the place that I'm going to work at uses a completely different language than I have used in any of the courses that I did in my undergraduate degree. That's where I want to go with this. When we're comparing languages, the very first thing that I want to do here is compare the programming paradigm. There are three major paradigms of programming languages. There are procedural programming languages. That's like Java, C, Python. These are procedural programming languages. Some of them have parts of object-oriented coding or styles attached to them, like Java is a partially object-oriented programming language, but it's fundamentally a procedural programming language. Functional programming languages are languages where all you can do is write functions. There are no classes. There aren't even really objects. There's data, but the data that you're passing around is just going to be operated on by functions. Pure functional programming languages have functions that do not change global state. They can take an input, they can transform it and return something, but they don't change, like, variables that exist outside of that function. Logical programming languages are like this entirely different idea, completely out of left field. If you take Comp 3190, that's artificial intelligence, you might learn a programming language called Prolog, and this is a logical programming language. Logical programming languages work by basically describing what the solution is to a problem, and then the programming language infers how to get there. It's a very different way of thinking. It's super, super different in terms of how you're thinking about things. If you are just finished graduating university, you've got this job offer, and you've never done C# before in your undergraduate classes, you can look at C# and say, this is a procedural programming language. I am comfortable with procedural programming languages. I should be able to get started in this fairly quickly. After looking at that major difference, it's starting to look at some of the smaller differences and similarities between the language. And this is going to be like looking through source code. So taking a look at some examples of what this source code looks like as you're going through it. Different programming languages have different primitive types, but also just different names for the same kinds of primitive data types. Different programming languages will have different approaches for declaring variables. So I'm going to pick on JavaScript here for a minute. In Java and C, when you declare a variable, you declare its type, and you don't have to give it a value. In JavaScript, when you are assigning a value to a variable, that's when you're declaring it. And there's no type. You're just giving a value to a variable name. So in Java and C, you start by giving a type and declaring the name of something. In Python and JavaScript, you just assign a value to a variable name, and it comes into existence. There are some differences between languages that are like that, but ultimately it means the same kind of idea. A variable is a variable in these languages. Control structures are another place to look when we're comparing things. In Java, we have these for style loops that are like declare an integer counter, have a test, and then an incrementing stage at the end. In Python, we have really only for each style loops. And this again goes back to what I was talking about yesterday with the best practices. Python only has these for each style loops that you don't usually break out of because the intent is to apply the same operation to the entire sequence of things. In Python, it's actually not super straightforward to do a non-for each style loop and be able to break out of it. There's an extra layer of you have to add something to your for loop to get counters to be able to do something with that. With Java and C, the control structures are effectively identical, and we'll look at that again. We saw it last time. We've got a while loop structure. We've got if statements. We have for loops. It's effectively the same thing with Java and C. And then once we've done taking a look at some of the smaller differences and similarities, we're going to look at some of the bigger differences and similarities between the languages. So let's take a look at some primitive data types. This is a list, a fairly comprehensive list of the primitive data types in Java. Has anybody used short before for anything? Okay. How about byte? One person, two people, sort of. Okay, two people, sort of. These do exist in Java. They are types that are available for you to use. You may not have used them before. The thing that I'm looking at in this table is how many bits do I have to work with in this data type? Java is a programming language where when you compile your code, your target is the JVM. The JVM says that when you declare an integer, what you're asking for is 32 bits of memory to represent a number, either positive, negative, or 0. When you declare a short in a Java program, you're telling this JVM that you want to use 16 bits of space to represent a number, positive, negative, or 0. In Java, when you use the long data type, you're asking for 64 bits. That's a huge range of numbers that you can represent there. Float and double are floating point numbers, the ones that have decimal points in them. Char is a single character. It's 8 bits wide. A byte is it's a byte. We've all heard the word byte before. Yes? Okay, so a byte is 8 bits. And then a nibble is 4 bits, because it's just half a byte. Ha 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 ha. Yes, please laugh. Please actually laugh. Yeah, okay. Boolean in Java, I mean, I don't actually know. It's a true or false value in Java. Maybe it's 1 bit. It's probably not 1 bit, but it could be as small as 1 bit because it's just a true and a false value. When you write a Java program, you're targeting the JVM, the Java virtual machine. That means that when you compile your code and you put it on my machine, which has an AMD processor on it, and when you send it to this person in the front who has a Mac, is that an M2 Mac? M1 Mac? Okay, so it's still an ARM processor. So the same kind of thing that you got on your phone. If you've got a Java program that runs here, you can send it to that machine, and it will still have 32 bits for an integer. It will still have 16 bits for a short. It will still have 64 bits for a long. This is just true of all JVMs. The C programming language, it kind of depends on which architecture that you're using. On some architectures, the long data type means 32 bits. On that laptop, it's 64 bits. On some older Intel laptops, it's 32 bits. The JVM guarantees that long will always be 64 bits. When you compile the same C program on different computers, it kind of depends on which architecture you're using. So AMD or Intel or x86 or ARM as another kind of architecture that you can think about. So these words are also present generally in C. So int, short, long, float, double, char. Byte is not a keyword in C. There's no data type that's called byte. The synonym for that is just char. They're the same. And there's not really a Boolean type in Java. In C, it's just kind of like 0 or non-zero numbers. Declaring variables between the two languages is really quite similar. One subtle difference between C and Java is that C has unsigned variants of numbers and also technically characters, but usually we're only using this with numbers. Unsigned effectively means that you can double the range of numbers that you have, sort of. So the range is the same, but they can only be positive numbers. So with Java, I forget the exact numbers, but an integer is like -2 billion to +2 billion. An unsigned number is 0 to 4 billion. That's the kind of thing that we're looking at here. We just take the part off that represents what the sign is. We're probably not going to be using unsigned too much in this course, if at all. Unsigned is important when you get to places like operating systems and you're starting to work with file systems and you need to guarantee that I have exactly 32 bits of space to use. For our purposes, we're probably not going to be using that, but it is something that is in the language. So if you're reading C source code and you see the word unsigned in front of a variable declaration, that's basically what it means. This is positive numbers only. Yeah?
In the context of some microprocessors, they don't really recognize, like, if you say int and you have to specify uint32t or uint16t, what's going on there?
Okay, so I'm going to go back to this slide. The question you're saying is uint32t, uint16t. uint32t and uint16t, you can all shut your brains off for a second if you want. uint32t and uint16t, these are coming from a library called stdint.h. And what this library does is it lets us specify precisely, I want 16 bits of space. I want 32 bits of space. If I just declare an integer, if I compile it on my machine versus that M1 Mac, it's going to be different. If I just say int. If I say uint16t, it's going to be 16 bits on both machines. So using that specific library lets us kind of force the C compiler to allocate that much space for that variable, whereas using these basic types doesn't give us the precision that we would want for something like that. So it's not so much the microprocessor itself that can't recognize it. That's more of me as a programmer, I wanted to specify exactly how many bits wide this thing is going to be. And again, that actually gets into operating systems. When you're thinking about like decoding a file system, when you're looking at the file system, there are fields that are 32 bits wide. I don't want to use a long here, because if I use a long and compile it on that machine, now it's going to take up too much space when I'm trying to read that thing from the source. Does that make sense? Okay, good. Okay, so representing, declaring variables is effectively the same. We can declare variables here without giving a value. We can declare variables and initialize them at the same time. We can add unsigned here, and this is going to make sure that we can represent only positive numbers. Tiny aside, it doesn't mean you can't assign a negative number to an unsigned integer. It just means that it's only going to be represented as a positive number. Exercise for the reader. Create an unsigned variable and assign a negative value to it and see what value it actually has when you print it out. Control structures are really similar to Java between C and Java. C has all the same control structures that we have in Java. If, while, for, and switch, and they all effectively look the same. The main difference between C and Java is that C doesn't really have a Boolean type. There is no basic primitive true or false literals in the C programming language. Asterisk. You can actually use any variable in place of a Boolean expression where 0, any value that is 0 is false. It means that this is false. Anything that is not 0, so positive numbers, any positive number is a true value in a C program. You can get true and false literals from this header stdbool.h so that you can have the words true and false appear in your C source code. But these really are just 1 and 0. That's ultimately all they're going to boil down to, is they just represent the numbers 1 and 0. This is a tiny loop here. I've declared this variable called I. I have just said while I don't have greater than 0. I don't have anything else. I just say while I, and then within the loop structure, I'm decrementing i's value. This loop will repeat until I is 0. Every time we get to this expression where we're testing to see whether this is true or false, all this will do is say, is this 0 or non-zero? While I is greater than 0, this will be true. When it becomes 0, this will be false. True and false are just 1 and 0. That's the main takeaway from this. I do not tend to write code that relies on this fact. When I want to express a relational expression between things, a logical expression between things greater than 0, I will explicitly write greater than 0. I want to make sure that my intent to the person who's reading this code is clear. The intent here is not clear, but this is a common practice that you see in C programs. I'm not going to do that, but you might see this in the wild. One thing that we saw when we were going from toLower.java to toLower.c was the introduction of libraries, and we've been kind of seeing this from the very first C program that we wrote. The small difference between the languages that we've got right now is pretty small. We're using this number sign include instead of import, and then package names after it. A big difference that I'm going to get to a little bit later today is that these things that we're including, so this thing that says .h, this is a header file. This is a file that lives somewhere on my machine. Header files typically only declare functions. Now this part is already kind of a little foreign, that I've said the word declare function, and I haven't talked about just like making a method. We're going to talk about functions soon, but there's two parts to functions in C. There's the declaration of a function to say that this is a function that exists somewhere, and then there's the definition of a function, where you actually put the body of the function in the code that you're writing. Header files, stdio.h, stdbool.h, ctype.h, these only declare functions. The actual function definition exists somewhere else. This is a big difference that we can overlook for now. It's not yet important for what we're thinking about, but it is a big difference between the two languages. Let's take a look now at some of the bigger differences from Java. As I'm going through this part, I'm going to open my editor frequently. Again, please code along. The purpose here is not to get like a fully working program. My primary goal is to get you to be able to type C programs in, to get comfortable with that. Let's take a look at some of the bigger differences from Java, or affectionately, what I'm actually going to do now is kind of go through this process of kind of saying, what the fuck, C? Why is it like that? What's going on here? This is what we do in Java. Java was made in the 80s and 90s. This was at least 10 years after C was initially made. There are good ideas that are in Java that we currently take for granted that do not exist in C as a programming language. So when I say this, I mean it like affectionately. This was maybe a bad idea at the time, but they couldn't have known that until they actually tried it for a while, and then someone figured out that there's better ways to do it. But for some reason, all these maniacs just kept coding in C anyway. Declaring variables has some subtle differences between Java and C that don't exactly make a lot of sense. Here's the first one. In C, you don't need to initialize a variable before you use it. You might have seen this sort of in Java. So when you declare an array of something in Java, I'm going to pick on arrays of integers. I'm going to say int array is equal to new int array and then size. All the values in the array are 0 by default. In C, uninitialized variables are not guaranteed to be 0. They're not guaranteed to be 0. This really depends on the OS, though. Some operating systems will initialize them to 0. Some operating systems will just initialize them to random values. Some operating systems will just reuse memory, and whatever value was in there before will be what's in there right now. Let's take a quick look at a Java program, and let's take a quick look at a C program that does this. I'm going to go back to my home directory. I've got 2 panes open here. I want to start making a directory structure that contains the examples that we're doing in class. I recommend that you have something similar for the code that you're keeping track of in class, so examples and assignments as separate directories. I've already got a comp2160 directory, so I'm going to change into that directory in both cases. And within here, I have lectures. You might also have an assignments directory. I'm going to change into the lectures directory. This is lecture 4. So this is where my examples are going to live for today. I'm going to write a Java program here called uninitialized.java. I'm going to verbalize Vim today, and next week I'm probably just going to stop. Just so we can keep track of what's going on here now. Next week I'm probably just going to start typing into Vim, assuming that everybody's either using VS Code or is learning Vim on their own. So I'm going to say public class uninitialized. I'm going to say public, please chant along with me, static void main string args. Thank you. Public static void main string args. I'm going to create an integer. What should my integer be called? What? It? A. A is a bad name for a variable. Some int. That's not imaginative enough. Age. Okay, great. In Java, if I try to say system.out.println, age is plus age. I write this, so I'm in insert mode. Right now, I'm hitting escape on my keyboard. I'm doing shift : and then W to save it for write. I'm going to switch over to this terminal here. I'm going to do Java C uninitialized. When I try to run this, this is a compile time error. This isn't a syntax error. There's nothing wrong with the syntax that I've written, but I cannot compile this code because I have not initialized this variable. This part, excuse me, is not the interesting part. So if you haven't gotten all that down, that's totally okay. I'm going to write on this side uninitialized.c. I'm going to enter insert mode by hitting I on my keyboard. I'm going to do, please chant along with me, number sign, include stdio.h. Thank you. stdlib, thank you. Number include stdlib.h. I'm going to start doing my main function. Int main void. I'm going to do void this time. Thank you. Good. Yes, void. I'm going to say the same thing. Int age. And I'm going to say printf. Last time we printed out a character, we used %c for characters. I'm going to do %d for digits or decimal or numbers. And I'm going to say age is %d \n. Println gives me the new line character. Printf does not give me a new line character, so I must put it there. I'm going to close my string, and then I'm going to pass age here. And then I'm going to say return exit success. I'm going to go back to my Java program, and I'm going to quit this one. So I'm out of insert mode. I'm in command mode. I'm hitting colon and then Q to get out of Vim and pressing enter. Now I'm going to compile the C program. I'm going to compile it with the command that I have given you. So including that WAL flag, clang-WAL uninitialized.c. I've got lowercase u. I'm hitting tab, and I'm completing this with my tab key. I'm going to say -o uninitialized. I'm hitting tab again here to sort of complete this, but I'm going to delete the .c part of it just to save myself a little bit of typing. We get a warning. The warning here is this variable called age is uninitialized when used here, and it gives me this nice green little arrow here. There's a hatch and some tildes. But it did compile my code. It did compile it. So I do have this program called uninitialized. I'm going to run it. I'm going to type UN and hit tab. What do you think this is going to print out? So I'm hearing both 0 and random number. Okay, so like keep it in your head, and then cheer if you win. Yay! And it changes every time. Did you type this in on your Mac? And what does it print on your Mac?
3 times I got 448 336.
Okay. Did you get 0 every time? You got 0 every time? You got 0? 0, 0, okay. So not only does it depend on the operating system, but it appears to depend on the computer. But it was fine. We were able to compile this program. One of the things that we're assessing you on in the assignment is this. These warnings are here to help you stay out of this situation, where not only am I getting different values every time, but even among the people in this room, the output is different. These warnings will help make sure that our output is consistent across any machine that we are using. Okay, have we got this? Can I move on to the next thing? I want to make sure you have some time to type this in if you're still typing. You're good? Thumbs up, please, if you're done. Okay. Declaring arrays in C is very similar to Java. It's different. It's clearly different. There are some different parts to what we can already see here than what we have in Java. In Java, we have to initialize an array We can declare it as an array with square brackets, but we give it a size by initializing it. We say is equal to new type, and then inside the square brackets, we say how many elements that we want to have in that array. We will eventually in this course see that yes, you can do that in C, but for now we're going to declare arrays this way. We're going to declare them by giving the name of the variable, the type, and the size of the array all in one kind of nice little package. Declaring arrays is very similar to what we have in Java. The big differences between C and Java with arrays are that arrays are not objects. So super quickly, I'm going to type this. You do not need to follow along. I'm going to say vi arrays. I'm going to call it myArrays.java because there is a class in Java called arrays, and I don't want to conflict with that. So public class myArrays, public static void main string args. When I declare an array in Java, I will say int ages with square brackets is equal to new int, and I'm going to say 10. There are 10 elements in that array. In Java, I can ask questions like system.out.println ages array is plus ages dot length elements long. We are able to ask this array questions about itself. This is explicitly saying here, this dot length is saying, tell me how many elements are in you. Please, you object, instance of class, tell me how many elements are inside of you. In C, arrays are not objects. They are not objects. We're going to get to this next week. Technically, arrays are just addresses in memory, only addresses. They are nothing else. We will talk about this more next week. For now, all we need to know is they are not objects. They're not an instance of a class that we can call things on. To go even further, nothing is an object in C. C is not an object-oriented programming language. There are not things that we have that have data right now or methods. We cannot invoke behavior on a thing in C. Arrays themselves, when we declare them, do not have a length property. They don't have a length property in C. Arrays, unlike Java, are probably not initialized to 0 when you declare them and start to use them. In the same way that we are able to use uninitialized variables, even if we're declaring an array in C and saying it's got 5 elements, those 5 elements are not guaranteed to be the value that you're expecting them to be. In Java, you can expect it. In C, you cannot. It depends on the operating system, and again, apparently it depends on the person's computer or version of operating system that we're looking at. Arrays are not bounds checked in C. We're going to come back to this in just a second, but asking for an array at element -1 is perfectly valid. It's not even a syntax error. It's not even technically a runtime error. This is just something we can do. It is not bounds checking arrays. If you know Python, this might look familiar. Give me the last element in the array. It does not mean the same thing as it does in Python. Really technically, this literally says, give me the element before the array starts. Really technically, it says, give me the element just before the array starts. This is related to it being an address, and we'll talk about that more next week. Yes? Would you ever use this for anything? No, I would not ever use this for anything. Could you use it for something? Maybe, but not reliably. The element just before the array starts is sometimes the function or the return address. And doing things before the array starts kind of messes with stuff in ways that are unpredictable. On some operating systems, it will do nothing different. On other operating systems, it will cause your code to crash. Yeah. In Java, when we were declaring arrays, we always had to declare them like this. We always had to say, I'm going to declare an array, and I'm going to assign to it using this new keyword, and then the size of the array that I'm going to create. We always had to do that. We were required to do that. We're going to talk, again, more about this later. I'm sorry to keep saying we're going to talk more about this later, but I want to get through syntax, and then we'll start talking about things that are below the syntax. On Java, arrays and objects, so instances of classes, are heap allocated. Have you ever seen this word before, heap? Anyone? Everyone. Where did you see the word heap? In 1020? Data structures, yeah, okay. So you've heard of heap as a data structure then. Okay. Arrays and objects in Java are heap allocated. Primitive types on Java are stack allocated. I know that you've all seen the word stack before. I know that you're all aware of a stack data structure. These two things in the context of what I'm talking about right now are different parts of memory. Again, we'll talk about this next week, but there are different places where things are going in memory. In C, I'm going to quit this now. So escape, I'm out of insert mode. I hit :Q to quit. I'm going to say vi arrays.c. And I'm just going to really quickly type this stdio and stdlib thing. Int main void. In C, when we declare an array and when we declare primitive types, we get to choose where they go in memory. These are both stack allocated. So if I say int age, this is a stack allocated primitive type. If I say int ages 10, this is also a stack allocated array. There is no new keyword in C, but we will call a function later that's called malloc to ask for memory. Once you've got an array, using it is the same as in Java. So I can say things like ages at element 5 is equal to 39. And I can say things like printf %d. Franklin is years old. Ages at element 5. Going to put this on the next line so it's a little easier to see. Declaring arrays, initializing values within an array, referring to values within an array. It's all effectively the same as in Java. Yes, please.
What's in all of the 9 other elements?
Let's write a loop. I'm going to come back and change some parts of this in a second. I'm using a for loop here because I plan to iterate over every element in the array. I'm going to say element %d is %d \n I ages 5, I. So I'm going to escape out of insert mode, :W for write. I'm going to exit my Java program here. I haven't written it, so I'm going to say WQ to write and quit. I'm going to say clang WALL arrays.c-o arrays unused variable age. I'll comment this out for now. Okay, so predictions. We know what element 5 is. Are they all 0? Are they all random numbers? What do we think? All random? It's all random, but only one of them is changing. I'm going to switch back to my slides, and then I'm going to come back to the same file. So if you haven't finished typing this one in, that's okay. It will come back. The first recommendation that I have for you when you're working with arrays is to declare their size as a constant. In C, in Java, you have the final keyword to say this is a value that can be assigned one time and then never again. So you have probably seen things like public static final string, all uppercase, and then a value that you want to assign to it. Public static final int, so a class allocated, a variable, a constant variable attached to a class. In C, we don't really have a const type. We don't really have one. There is a const keyword. We're not going to talk about that in this course. But we have something called the preprocessor. The preprocessor effectively gives us the ability to declare constants, but they're not variables. They're not variables. We'll talk about that in a little bit. When we're working with arrays, use the preprocessor to define the size of the array. I'm going to switch back here. And what I'm going to do with this is I'm going to use my preprocessor to allocate the maximum length of this array. So I was in command mode. I'm entering insert mode by pressing I. I'm actually going to enter insert mode by pressing O on my keyboard right now. O enters insert mode and adds a new line to the file that I'm working with right now. It adds one to the next line. Uppercase O adds one just above where you were before. To declare, and I'm putting big air quotes around this, to declare a constant variable using a preprocessor directive in C, we use this number sign, then the word define. We're going to give the name of the constant variable, again, big air quotes here, the constant variable. I'm going to say ages length. I use underscores to separate words here because they're all uppercase. And I'm going to put 10. These preprocessor directives do not have semicolons at the end of the line. There's no semicolon at the end of the line for a preprocessor directive. Once I have done this number sign define, I can use this throughout my code. So I'm going to switch this from 10 to ages length. I'm going to switch this from 10 to ages length. If I've got an array, this is me now telling you that you must do this. If you're declaring an array that's on the stack, you must use preprocessor directives to say how long that array is. We okay with that? Yes? It's okay? Yeah.
Is there a reason it's not indented like the others?
This is my personal preference. You can indent it. I think you can indent it, but when we're running the preprocessor, it's almost typically that they're going to be immediately at the beginning of a line. So I'm going to leave it that way. Yeah. So the question is it better to put it at the top of the file? So is it better to put it, what I'm doing here is on my keyboard, my cursor is at this line 7. I'm pressing D twice on my keyboard. So DD is cut the current line, and I'm going to move up, and I'm going to paste it with P. Is it better to do it here? I prefer to do it closest to where I'm going to use it. So if I'm going to declare an array that has a certain size, it's in scope of the main function. So I want to put it in scope. I want to put that definition in the same scope as the main function. We're going to find out that it actually doesn't really matter. What matters is that we do it before we use it. That's the main thing that we care about. But when I do it, I put it closest to where I'm actually using it. So on my keyboard right now, I'm going to hit U to undo and U again to undo. Is it weird that you got the same value every time? Well, not really. For the output of the array, you mean? No, it's not weird. And in fact, if you looked again at what I was running here, it's the same except for that one element. Every time I run it, it changes just that one element. Okay, I'm going to switch back to my slides. When you're using arrays, initialize them to something that is known. Either use a loop to iterate through every single element in the array and give it a value, or you can use this initialization syntax. These are curly braces, and then a value that you want to assign to everything. A really common value to use for this is 0. Make all of the integers in my array 0. So I'm going to switch back to my code here. I'm going to initialize this array to 0. I don't have to put 0 for every single element. This is a shorthand syntax that just says all elements are now 0 in this thing. I'm going to write this, so exit escape mode, W. I'm going to go back to my other terminal. I'm going to compile this. Here's a little tip. You can also press up on your keyboard to get previous commands that you've entered in your shell. So rather than typing out clang WALL each time, if you're not using the same shell that I am that has this auto expansion, you can press up on your keyboard to just get back to that same command that you've entered before. So now when I run this, arrays, each time that 1 is going to have 39 because I've explicitly set it to be 39, but the rest of the array is going to have zeros in it. And then predictably, and this is going to be true on everyone's machine if you've initialized the array to 0. Yes? Can I use -1? No. So 0 is specifically shorthand notation for initialize the entire contents of this thing to 0. If you want to give specific values, what this is doing is initializing them all to 0, setting just the first one. The rest of it would be like populating them one by one. I prefer to just use 0 because I know that they're all going to be the same at that point. Okay. All right. Okay. Memory is kind of like this giant array. When I talk about memory, I'm thinking specifically about the RAM that you have in a machine. So random access memory, this is what your program is running in, where it lives when it's running on the operating system. I'm using a specific word here because I will use this word. You may not have seen this word before. I'm going to use this word in this course, contiguous. What that means is that physically, each element in the array is next to the previous element of the array, and it's physically next to the next element in the array. When we look again at arrays being addresses, it means that one address is literally physically next to the next address. Arrays can be placed in stack memory or heap. We have just done stack memory. We have not done heap memory yet. Java doesn't give you a choice. Okay, so exceptions. I want to pop this open quickly. What kind of exception do you see the most when you're writing Java specifically? Or you can just shout it out if you want. That's okay too. I just need to drink some coffee for a minute. All right. So one person sees Stack Overflow exception the most. I trust that's because you're doing a lot of recursive something. I don't know what. Null pointer exception is by far the winner here. Array index out of bounds exception. Obviously, if you're working with arrays a lot, you're going to see it. But at least in 1020, by the time you're getting to the end, you're mostly working with classes and objects. In C, we don't have exceptions. I've said this verbally before. Now I'm telling you for sure. C does not have any exceptions. There is no try-catch. There is no bounds checking on arrays. I'm going to write some code that crashes in Java and in C. So very quickly, I'm going to say vi crash.java, public class crash, public static void main string args. I'm going to say int ages is equal to new int 10 system.out.println. I don't even need to do that. I'm going to say ages at 30 is equal to 200. And then I'm going to quit this. I'm going to say javac crash.java. It compiles. This is a runtime exception, Java crash. I get array index out of bounds exception. When this fails, it tells me why it failed. It tells me a little bit about specifically what it's telling me how it failed. And it's telling me where it failed. Those are useful pieces of information to have. In C, I'm going to quit this, and I'm actually just going to open up arrays.c again. I'm going to say ages length times 10. Do we all agree that this would give us array index out of bounds exception? If this was in Java. If this was in Java. If this was in Java, do we all agree that this would give us array index out of bounds exception? I see 2 people nodding, and those 2 people, that's confidence enough for me. I'm going to say clang wall arrays.c-o arrays. Whoops, I have typed extra letters here. So I'm pressing U on my keyboard to undo, and then I'm pressing Control R on my keyboard to redo. And then I can also just delete things in command mode by pressing the delete key on my keyboard. Not backspace, but delete. Delete will let me delete things even when in command mode. Compile this again. I will run arrays. Awesome. I'm going to make this times 100. I'm going to compile this again. I'm going to run it. Cool. I'm going to start at -1. It's just fine. I'm going to do something where I'm going to pipe this into a pager. I'm going to send the output from that program into less, the pager. Element -1 is -1. I'm going to start at element -100. I think you kind of get the point. There is no array index out of bounds exception. I'm going to modify this just slightly, and I'm going to say ages at I is equal to 50. I'm going to quit this, I'm going to compile this, I'm going to run it. It's fine. I'm going to say minus 1,000. It's still working just fine. I can make changes to this memory that's somewhere that's outside of my array. I'm going to revert all of this stuff. I don't want to give this to you. I want to give you something that works. There is no array index out of bounds exception. There's no bounds checking on arrays at all in C. That is all that's kind of left up to us. We didn't see this today. Lots of you see null pointer exception. Your hatred is going to move from null pointer exception to segmentation fault. That will haunt you for the rest of your days, You're going to see the word segmentation fault a lot when you're starting to code in C. That's okay. When we get to doing debugging stuff, it will help a lot with the word segmentation fault. Strings are not objects in C. Strings are not objects in C. Strings in C are just dumb arrays of characters. Arrays in C are not objects. They do not know their own length. Strings in C are arrays of characters. They are just dumb arrays in C. There are no methods. There are no properties. We cannot ask for a string to tell us how long it is because the string doesn't know how long it is. It's just a dumb array of characters in C. Strings in C are not immutable. Have we seen this word immutable before? Okay, some people haven't. Immutable means that once you create a string, you cannot change the contents of the string in Java. The only way to change the contents of a string in Java is to make a new string. In C, a string is just a dumb array of characters. You can change anything that you want about it. It's just a dumb array of char. Strings cannot be assigned like they can in Java. You cannot take one string and assign it to another string like you can in Java. Strings are just dumb arrays of char in C. Strings can be declared as either arrays or as something that are called pointers. We're going to talk about pointers later in the course. We're going to just leave it where we are for now. Strings are just dumb arrays of characters. We can declare strings in C by declaring an array of characters and then assigning to it a string with double quotes. We cannot call methods on a string, but we can do using this other notation for strings, which is asterisk. I'm going to actually do two things at the same time right now. I want to do strings and I want to do functions kind of simultaneously. Given where we are in time right now, I just want to do them both at the same time. Functions are pretty similar to Java methods. Functions have a return type or voids. They have a name. They declare parameters with types and names. The main difference between Java methods and functions in C is that functions must be forward declared. What this is saying, or what I'm saying when I say forward declared, is that you must declare a function before you can call it. You can define a function after the codes, you can define the function after where you're calling it in your source code. But you must declare it before you can call it. What I want to do right now, in the last dying minutes of class, is I would like to write a strlen function. I want to be able to ask how long a string is in a function. That's what I want to be able to do before we're done today. So I'm going to quit this. I'm going to open up a new file called strings.c. I'm going to include stdio.h, and I'm going to include stdlib.h. I'm going to say int main void. I'm going to declare an array of characters, so a string. I'm going to say char brackets name is equal to Franklin. You are welcome to insert your own name here. I'm going to return at the bottom of this exit success. I would like to write a function that will tell me how many characters are in this string. The function that I'm going to write has a return type of int. I'm going to call this mysterlen. I'm going to call this string underscore length. What string length takes as input is an array of characters. So char, square brackets, the string, and then semicolon. This is my forward declaration. I have declared it before I am going to use it. I'm going to call this function from my main function. I'm going to say int length is equal to string length, and I'm going to pass name to it. Then I'm going to go to the bottom of my file. In Vim, I can go to the bottom of my file very quickly by pressing uppercase G on my keyboard. So Shift and then G takes me to the bottom of a file. I'm going to enter insert mode here on the next line, so I'm going to use O to go to the next line. I'm going to now define my function. My function definition starts with the function signature again. So int string length. I'm going to get out of insert mode. I'm going to go to the top of my file with lowercase g twice. Press G twice, that takes you to the top. I'm going to move my cursor down to line 5 here. I can copy a line in Vim using Y twice. So Y is for yank. I don't know why they picked yank, but that's what it is. So I press Y twice. Now it's copied. I'm going to go back to the bottom of my file with uppercase G. And I'm going to press P on my keyboard to paste. I want to go to the end of this line, so I'm going to hit $sign on my keyboard. That takes me directly to the end of the line. I'm going to delete this, semicolon, and I'm going to go to the next line, enter insert mode on the next line with O, and I'm going to open a curly brace, close a curly brace. Strings in C are dumb arrays of characters, but they do have one specific property that we can count on. The last element in a string in C is the null byte. The null byte is the character \0. That is a special value that says this is the end of a string in C. So I'm going to say int length is equal to 0. I am initializing my variable. I could not initialize it. That's possible. I am initializing my variable. I'm going to count every character in this array, but I don't know how many there are. For or while? Please shout. For or while? While. This is an event that's going to happen. I'm going to be counting. The event that happens is that I'm going to see the null byte in a string, in an array of characters. So what I'm going to say is, while the string at element length, okay, so I'm reusing the same variable, is not equal to the null byte, length plus plus. This will step us through each element in the string. So in this example, I've got my name, so it'll be Franklin. And then once it gets to n, we will increase length by 1. And the thing that we did not type in, but what we're getting from the C compiler is that the last element in that array is this \0, this null byte. So I'm going to say here, return length. The important takeaways here for functions, we'll revisit this on Monday. The important takeaway right now is forward declaration. We must declare the function before we can call it. We can define the function later, after the main function. The other thing that I'm going to tell you about is that when we're passing arrays to functions, this is an exception in that we have not specified the length as an argument to the function. In this case, we're literally trying to find out how long it is. So it makes sense for us to not pass a length because we don't know how long it is. In other functions that you write, including with strings, it's probably a good idea, instead of constantly recalculating how long the string is, to just pass that as an argument to the function. Okay. This will be posted to the course webpage shortly after I get to my office today. I'm going to skip ahead here past this part of the compilation stuff. At this point, you should, again, continuing, be able to recognize some potentially risky programming techniques and how they differ in different high-level programming languages. You should compare and contrast C a little bit, so you have some more ideas of how these two languages are the same and different. You should be able to declare, initialize, and use arrays and strings in a C program, idiom preprocessor directives to define the length, passing array lengths to functions as an argument. You should, at this point, also be able to declare and use user-defined functions in a C program. This part we will get to on Monday next week. I hope that you all have a great weekend, and I will see you on Monday. Goodbye, everyone.